This video could change your life, but probably not. What I'm going to show you how to do is engrave a nice curved surface over the top of the box that you milled out. So you're going to need to create a new part in Inventor, and I'll just kind of show you this really quick. It's a 4.5 by 3.5, as you can see there, and we extruded it to 0.75 inches. So that's the size, exact dimensions of this box. Once you have this box created, then you need to put some sort of pattern or design in the top. I'm going to do something very simple. So we'll just create a sketch. I'm going to create it on the long side here. And the first thing we need to do is we need to make a reference line, because remember, your box has this milled out part on the bottom. And if you cut too deep, you're going to cut a hole right through the top, and that's going to be bad. You'll have holes showing in the top of this thing. So we have a reference line there, and this should be 0.3. Ooh, that was close. 0.3 from the top. So it's actually cut out down here. That'll give us about 0.15 of an inch of safety as long as we make our cuts above this line. So that's just a reference line. So I'm just going to do a very simple arc. No, I'm going to do a spline interpolation because I am daring. And I'm going to make sure that this is underneath, so I'll click the check. It's underneath this top portion here. You don't want it to go up above it, because then when you extrude it, it won't really work. All right, so that looks good. We'll finish that sketch, and we're going to extrude this, and you can see that it's actually not extruding this top piece. The reason for that is because I haven't enclosed this. So I actually need to go back into this and edit this, and we'll just build a rectangle around the whole thing and then finish it. And now it will let me extrude that, and we'll cut it, and we're going to do the distance all, and then we're done. So then I have this fun little curve here, and after you mill this out, if you decide, hey, I want to engrave something on the top of this too, then you should do that. So we have the design is totally done, and it looks awesome. So now I'm going to go to CAM, and we're going to set this up. So we're going to do setup first, and we need to put our dot in this corner. It needs to be in this corner right here. Make sure that you don't put it on this side, because it will not clamp in the clamp. So this corner, that would be kind of the same corner there too. So let's change this. If I click the stem of the Y and it chooses this perpendicular surface, then Y goes perpendicular to that, which is what I want. Let me reverse the Z, and now if I reverse the Y, then I have Y going along the long side, which is what you need, X going along the short side, and Z going up. So that looks really good. Now let's go to stock, and I need this to be a fixed size box. My width is 3.5, my depth is 4.5. That's the size of the box, and the height of this thing was 0.75. But if you do that, if you take a look here, it's kind of centered it in there, which is not what I want. I want the bottom edge to be at the bottom of my stock, because that's kind of the value that we're starting with. So I need to change my model position so that offset from the bottom is 0. So I'll double click that to highlight it all, just hit a 0 in there, and you can see it moved it up. So now it looks fantastic. And post-process is fine. We'll leave that program number. I click OK. We have our setup. Now if we choose parallel, we're doing 3D milling. We're going to parallel lace any type of curved surface. If you chose to do something different, if you wanted to like etch out a design or your name or something, just remember the bit size matters. If you make a gap that's less than 1/8 of an inch thick and we only have an 1/8 inch bit, it's not going to work. It's not going to fit in there. So you got to keep in mind the tool that you're going to use when you're coming up with your design. A curve like this is not going to be a problem. I'm going to use a tool in my ProLite 1000 because we're doing this in the mill now, not the router. And I'm going to use the 1/4 inch ball. We have a 1/4 inch ball mill. We have many of these bits. If you want to use something besides that, if you want to get more detailed, just call me over and let me know, and we can figure out what bits that we have. So I'm going to select that one. And the feeds and speeds are already set for that. Now I'm going to go to the geometry. I need this to mill out the selection, and the tool should be on the center of the boundary. So the selection I want to do is this. Even if I choose the bottom edge, that oftentimes works also. So I'm going to choose this top edge, and the center of the tool will go on this edge, which I need because it's a ball mill, so it's rounded. So it has to go all the way to the outside edge of this. And other than that, then that selection is good. We don't have to do anything else here. All of our clearance heights, our presets should be fine. As far as passes go, this is where you get to do your customization. I want my pass direction, I'm going to leave it at 0 degrees. My step over, the smaller your step over value, the closer together your mill lines are going to be. So I'm going to leave it at half of the thickness of the bit. You don't want to go much more or any more than that, actually. So if I have a 1/4 inch, half of that is an 1/8 inch or 0.125. And I don't want any stock to leave, so make sure these are all deselected. And then the linking, everything is fine there. So I hit OK, and it's going to run through the operation. You can see this is how it's going. It's traveling in that direction. So I want to simulate that really quick and show you. And I have my stock showing, my tool path will show, and I'll hit play and just kind of fast forward this. And you can see, it goes in that direction. If we hold it down here, it shows the machining time is 7 minutes 52 seconds. So it's important that you look at that because you're going to have to hang out back there and vacuum during the time that it's machining. So if I deselect tool path, you can see there's kind of these ridges on there. If I go back, so I'm going to close this, and if I go back to parallel lace, I'll double click it and change my passes, and instead of a 1/8 inch, I'm just going to pick some smaller value. I'm going to pick 8/100 of an inch, and I'll have it rerun that and then simulate this and play, and we'll just fast forward all the way through. You can see the lines are a lot closer together, so it's a smoother operation. And if I wanted to make it even smoother and kind of change the pattern, I could do another parallel lace, and the tool is already a 1/4 inch ball. That's already set. My machining boundary, I'll just do selection, tool center, choose this. As you remember, everything else is fine except for passes. But this time I'm going to say I want to have a 60-degree pass. And I want to make this one, I'm going to leave it at an 1/8 inch. And I hit OK. And then you can see it's going at kind of an angle. So if you want to do angles, if you want to do the math involved in this and try to get it to go from exact corner here to the corner here, you can probably figure that out using trig. If you want to have a crosshatch, some this way and some that way, then you do some at 0 degrees and some at 90 degrees. So if we simulate this, then the first pass, because it was a 8/100 of an inch, is 11 minutes and 50 seconds now. The second one is only 8 minutes. So total machining time, 11 and 8, roughly 12 and 8 is about 20 minutes. So we'll run this one, and then you can see it runs that one. And you're going to get kind of this little crosshatch pattern going on. So the smaller your increment, the tighter it is and the cleaner it is that you're going to have. So again, as we continue to change this thing, if we make it 0.06, it just becomes even smaller and smaller and smaller, the little crosshatch pattern that we get on this thing. So go ahead and set this up however you would like, however clean you'd like it. Just keep in mind the machining time. Now I've increased it to 12 and 15, so I got it 27 minutes. And I'm kind of going in the same orientation, which really is not recommended. You're not going to see much difference. Probably would want to go at 90 degree to each other at least. And once you're done with that and you're happy with it, then you can do a post-process. And we want to make sure this is set to the ProLite 1000 mil, and then change it to your name, Beatum the Bum, and post this, and then save this to a place that you can locate it. Make sure you know where you're saving it. And then it came up with the code, and so it's already saved. So you're going to open this code up into CNC Base and preview it. So I'm just going to do a copy of this really quick. Now I want to show you on CNC Base what this is going to look like. So if we create a new file and then you open your file up, or you can just open your file that you saved. I just copied it all and pasted it in there. We need to change our verify box. So we go to verify settings, change our stock. So now our stock in the X direction was 3.5 and the Y is 4.5. The height of this is 0.75. So we're just changing the dimensions to match the dimensions of the box. Origin now, we want it to start in the corner, not in the center like we did of the yo-yo. So that's going to be 0, 0, 0. Initial tool position should always be 0.1 above the box. You always want to start at 1/10 of an inch above the box. So now we hit OK, and I'm going to hit cancel. And now I need to make sure I select my tool. So I need to have a 1/4 inch tool. Now there's none made, so you can simply make one if you need to. I'm going to go to Tool 2. This is a ball mill. It's 0.25 ball mill. Diameter of 0.25. Number of teeth, all those things don't matter, not for this verification. Then you just need to go up to Tools and select your tool, that 1/4 inch ball mill, select it, and then just do verify and go ahead and verify it to make sure it looks the way that you want it to do, and then you're ready to mill it on the mill.